Mau lagi. Hari ini kita bahas tentang lomba yang lagi hot nih, SEAMO 2021. Ya, buat ingetin teman-teman, SEAMO 2021, SEAMO tahun ini bakal diselenggarain di awal bulan depan, tanggal 1 Oktober. Oke, jadi jangan sampai kelewatan. Registration sampai 23 September. Bisa langsung ke website. Oke. Kali ini saya mau bahas SEAMO Paper D untuk pas kebetulan ada yang nanya. Oke, kita bakal coba discuss ya. Kita langsung coba yang susah-susah. Nomor 8. Oke, ini caranya gimana sih? Ada yang nanya nih. Ini basic rule-nya, we just do divisible by 11. So, 9999. Oke, please don't be distracted. Do not be distracted. This is, we do this one first. 9, 9, 9, 9, blah, 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 blah. 9, and then there are 2021 of 9. Okay, please don't be distracted with the power. We will do the power at the end. Okay, so this, how to get this one? 9 divided by 11. The remainder is, yeah, I just want to know the remainder. Don't need the quotient. So the remainder is 9. Then for 99, 99 divided by 11. The remainder is 0. 999 divided by 11. The remainder will be 9 again. Yeah, remainder is, the R is the remainder, yeah. So it's mean like 999 divided by 11. The quotient will be 90. Because 90 times 11 is 990. And then we still have another 9. That is the remainder. Okay. So 909, there are 9, 4 9 in here, divided by 11. So the remainder will be 0. So we already know the pattern. If the number of 9 is odd numbers, so the remainder will be 9. If the number of 9 is an even number, so the remainder is 0. In here, the number of 9 is, there are 2021 9. Okay, so in here, the remainder is 0. 9. Yeah, in here, the remainder, okay, I write again, 9, 9, 9, 9, and there are 2021 here, divided by 11, the remainder will be 9. Okay, and then we will do the 3. Yeah, I will do the 3 with this one. See, don't do the power first. We will do the numbers first. So 3, 3, 3, 3, and blah, blah, blah. 3. There are 2021 3. Yeah, then do the same thing exactly with 9. Yeah, the same way. 9 divided, not 9, sorry. It's 3 divided by 11. The remainder is 3. 33 divided by 11. The remainder is 0. 333 divided by 11. The remainder is 3. 3,333 divided by 11. The remainder is 0. See? Exactly the same. So 333, 3, there are 2021 3 in here, divided by 11. So the remainder will be 3. Okay, the same rule, the same way. Okay, then for the next, we will do with the power. Yeah, so we have the remainder 9 already. So 9, we're starting from 9 in here. 9 in the power of 1, then divided by 11. The remainder will be 9. Then 9 in the power of 2 divided by 11. The remainder will be The remainder will be 81. It's 4. Then 9 in the power of 3 divided by 11. So the remainder will be 3. 9 in the power of 4 divided by 11. Then the remainder is 5. 9 in the power of 5 divided by 11. Then the remainder is 1. Then 9 in the power of 6 divided by 11. The remainder is 9. Okay. So, like this. I will show you. Of course, in practice, you can use calculator in practice. But in the competition, you cannot use. So, 9 in the power of 1 divided by 11. The remainder is 9. So, we can do it manually. It's so easy. 9 in the power of 2 divided by 11, 81 divided by 11, so the remainder is 4. Yes, it's still easy. But 9 in the power of 3, maybe some of you takes time. I will give you the way. So just do the R in here. The previous R with the first R. You times it. So 9 times 4, 36. Then 36 divided by 11. The remainder is 3. That's how I get it. Okay, so 9 in the power of 4. Just do previous remainder, 3, and the first, 9. 3 times 9 is 27. Then divided by 11, the remainder is 5. Yeah, and so on and so on and so on. Then, as we can see, that the number will be repeated. There is a pattern, 9, 4, 3, 5, 1. 9, 4, 3, 5, 1. That's for the 9 in the power of. Okay. So, if I'm asking in 9 in the power of 20 divided by 11, so the remainder is, we just do, because we have five numbers, I mean 5 different numbers in one pattern in here. See, 1, 2, 3, 4, 5. Yeah, 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So the remainder is 1. Okay, so we already have the numbers in here. Yeah, or just 20 divided by how many pattern in here? Because 20 divided by 5, and then there is no remainder. No remainder, it's mean the last one. If the remainder still, it's say remainder 1, so this is remainder 1, 2, 3, 4, and then this is 0. Okay, next. We do the same way with the blue one. Okay, so 3, yeah, because the result of 3 in the power of 3, and then there are 2021 threes divided by 11. The remainder is 3. Then we just do the remainder. 3 in the power of 1, we do the same thing, exactly the same thing. Divided by 11. The remainder is 3. And then 3 in the power of 2 divided by 11. The remainder is 9. 3 in the power of 3 divided by 11. Remainder is 5. 3 in the power of 4 divided by 11. The remainder is 11, 4. 3 in the power of 5 divided by 11. Then the remainder is 1. See, we have another pattern. Yeah, of course, we can continue like 3 in the power of 6 divided by 11. Then the remainder is 3. We're going back to the first one. Okay, it's already repeating. Then, this one. It still have 5. So, if 3, sorry, use another color. 3 in the power of 20 divided by 11. So, the remainder is 1. So, for the final answer, it's just 1 minus 1, which is 0. Okay. Okay, for the next number, we will do number 11. Next, number 11. Okay. This is challenging question. Even if you have calculator, you cannot do it. Okay. In here, I will do aspiration. Like 1001, 1002, and 1003. Yeah. I will make like this so that it's easier for you to count the sum of all digits. So in here, the sum of the digit is 1, 2, 3, 5, 6, 9. Okay, I will do 3 by 3 numbers here. 1004, 1005, 1006, 1007, 1008, sorry, 1010, 1011, 10 and 12, 10 and 13, 10 and 14, 10 and 15. And then 10, 121. 10 and 16, 10, 17, 10, 18, 10, 19, 10, 20, and 10, 21. Okay, we will do the sum. 18, 7, 8, 9, 24, 27. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 18, 27. This one, 9, 10, 11, 12, 13, 14, 18. So that their grand total is 126. Okay, in here, we will do the divisibility rule. Yeah, because it's 3. 3, the divisibility rule of 3, the way, yeah, I will give you the way. Sum, yeah, you have to sum of all digits is divisible by. Okay, because this is not only 3, I will give you an extended version. So sum of all digits divisible by multiple of 3. So like, for example, 3. Not multiple of 3, yeah, 3 in the power of. Uh, for example, 3. Divisibility rule of 3. So the sum of all digits is divisible by 3. And then divisibility rule of 9. Sum of all digits is divisible by 9. And then if 27, you do the same way. So in here, we just do 126 is divisible by 126 divisible by 9. Yeah, so the biggest number is 9. The other cannot. Yeah, as you can see this one already. Okay, if you divide by 27, it's cannot. It has remainder at the back. Okay, it's so easy. But if you want to prove it, yes, I challenge you to prove it manually if you have time. And then show it to me. Okay? So the answer for this one is A. And then for our last number today, the answer, the question is number 13. Okay. Okay, maybe some of you unfamiliar with this one, because actually this one you will learn this in secondary 4, if I don't wrong, yeah. Secondary 4, binomial expansion. If you take additional math, international school, yeah. If international school, I don't know, because I don't have any student in national school. Okay, for this one, you will use binomial expansion. Okay, I give you the formula first. Okay. Binomial expansion is talk about this. A plus B in the power of n. Yeah, in school we learn until maybe 2 or 3. 3 maybe. But in Olympiad we learn until, yeah, 10 is small one lah. We learn more than 10. Okay, so the formula is just like this. So it's sigma. Okay, sigma is the sum from I use R there. R equals to 0 until n, which is NCR. A in the power of n minus R times b in the power of r. Just like this. We will use this one. This is the complete formula. I mean, like, you can find all. But for competition, it's the question is not asking for all the terms. It's only asking for the constant term. Constant term is mean like x in the power of 0, or the term that is not, there is no x in there. Okay, so how to make it? At first, we will do like this. Okay, to make it easier, I will use a. Okay, in here, a is 2x squared. B is 1 over x3. Okay, and then the next, I will do like, for finding the r, we don't need to use the NCR first. We only do the a. Okay, we'll write 2x squared in the power of, the n is 10. Sorry, I forgot to put it. N is 10. 10 minus r times b. B is, okay, x in the power of -3 in the power of r equals to, since the constant term x equals to 0, then we just expand. Actually, I don't care about the coefficients, so we just do the variables. So 2 in the power of 10, because it's nothing changed. So x in the power of 20 minus 2r. Yeah, power and power again. Next, in here we can expand that, it's become x minus 3r equals to x in the power of 0. So in here, 2 in the power of 10, x 20 minus 2r minus 3r equals to x in the power of 0. So 20 minus 5r equals to 0. So 5r equals to 20. R is 4. Done. We just find one term. So for the final answer. Now, for now, we will do the complete form. Like 10. Wait, I will make a line first. Oops, sorry, I didn't. This is for the final answer in here. So the NCR. 10 C4. And then A. Now A. 2x squared in the power of 10 minus 4 times x in the power of -3 in the power of 4. Okay, in here 10C4, 10 times 9 times 8 times 7 times 6 factorial over 6 factorial times 4, 3, 2, 1. then times by 2 in the power of 6, and then x in the power of 12. And then in here, just x in the power of negative 12. See, we can cancel out the x in the power of 12 and x in the power of negative 12. The answer will be 1. Okay, I will use another color. This is 6 factorial. We can cancel it out. Cancel, it means it's become 1, yeah, not 0. This is also. And then 8, 4, and 2. And then 3 and 9. So the remaining will be 3 in here. Okay. Then the next, just 10 times 3 times 7. What is it become? 10 times 3 times 7, 30, 210. 210 times 2 in the power of 6. Times 64. The answer will be 13,440. Okay, that's the answer. Okay. Okay, I think enough for today. Okay. If you still have any question, just text me, just contact me in my Instagram, YouTube, WhatsApp, and I will try to make a video to explain for you. Okay, thank you.